Good morning. Today we are going to talk about multiple regression. The OLS. First of all, we are going to start with talking about the general model of multiple regression and then how to estimate the parameters. And then we are going to test the hypothesis regarding the validity of the parameters. And finally, we are going to talk about reliability of the model using R squared and F, using matrix notations. So first of all, the basic model. We can write the basic model in case of a multiple regression with two explanatory variables as y equal beta 1 x1 plus beta 2 x2 plus beta 3 x3 plus u, where y is the dependent variable. And small x1 is a constant with a fixed value 1. So the value of x1 is 1 for all observations, while x2 and x3 are explanatory variables or independent variables. So this means that our model consists of two independent or two explanatory values. U is the error term or the residual error term, error. B1, B2, and beta 3 are parameters. So now we would like to convert the basic model to the matrix notations. So we are going to use matrix and vector notations. We have to collect data for y. So y will be written as y1, y2, y3. So this is the observations of y. And then x. So with respect to y, it is a vector. And with respect to x, it will be a matrix 1, 1, 1, 1, 1 for x1, and then x21, x22, x23, and so on, till x to n for x2. And as we said before, that this is a two explanatory variable model. So we have x31, x32, x33, etc. So this is the matrix for the explanatory or the independent variables. And then with respect to beta, it is a vector, beta 1, beta 2, and beta 3. And finally, with respect to u or the error term, it will be a vector u1, u2, u3, depending on the number of observations. So we can write the basic model using matrix notations as y equal x matrix x beta plus e matrix, plus u matrix x multiplied by vector beta plus vector u. So this is the true model. And we would like to find the estimated version of this model. So we can write the estimated version as y equal xb plus e, where e is the residuals and b is a vector of parameters b1, b2, b3. Our main objective is to estimate use data for x1, x2, and y, x2, x3, and y in order to estimate the value of the parameters. So the objective is to estimate parameters using collected data for y, x2, and x3 in such a way the residuals sum of squares is minimized. The residual sum of squares, which is e squared, as we said before, in case of matrix notations, it's not going to be written as e squared, but it will be e prime e. So residual sum of squares is e prime e, which means e squared, e multiplied by e. This method is known as ordinary least squares, or OLS. So in order to achieve this main objective, which is to find the value of the parameters, we have to find the value of e. As we said, y equal xp plus e. So this is number 1. In order to get the value of e, we can write it as e equal y minus xp. This is number 2. As we said that our objective is to find the squared value of e, not e. So we have to get e prime e, which is calculated as y minus xp prime, or multiplied by y minus xp. So now we can get the value of e prime e as y prime y minus 2 b prime x prime y plus b prime x prime b. Then we have to get the first derivative of this equation and equate it with 0. So the first derivative with respect to b will be negative 2 x prime y plus 2 x prime xp. If you are going to equate it with 0, this is number 3. So we can solve it for the value of b. So b will be x prime x to the power negative 1, or the inverse of x prime x matrix multiplied by x prime y. So this is how to find the value of the parameters. So we can rely on this equation to find the value of the parameters. So now we have to understand how to multiply a matrix by matrix and a vector by vector in order to be able to find the value of the parameters. Let's take an example. This example will help you to understand how to get the parameters, then test the hypothesis for these estimated parameters, and finally we have to test the significance of the model. Well, let's start with a sample of 10 observations. So n equal 10 for consumption, income, and interest rate, where consumption is y, income x2, and interest rate x3. So this is the observations 1, 2, 3, 4, for example. Then we reach 10. With respect to income, it's 10, 12, 17, so on. And with respect to x3, it will be 20, 18, 17, and so on. Our objective is to estimate the parameters to find the value of B. Estimate this equation. We are going to apply or use the rule in equation number 4. So B will be calculated as the inverse of x prime x multiplied by x prime y. So what's meant by x, y, x prime x, x prime y, and inverse or x prime x power negative 1. That will be used in order to be able to find the value of B. With respect to matrix X, this is X. It's 1 for X1, 10, 12, 17, and so on. For X2, 20, 18, 17 for X3. So it is a matrix for all the data related to the explanatory variables. With respect to y, it is a vector. Taking the value of y. And then we have to multiply x by x in order to find the x prime x. So x prime x will be a 3 by 3 matrix with the values 10, 214, 116, so this is x prime x. We can find the value of x prime y by multiplying the matrix x by the vector y, and then we are going to get a vector of 3 by 1 vector, 55, 1348, and 472. Now we have to get the inverse of this matrix in order to be able to find beta. So the inverse will be 20.423 negative 0.608 This is x prime x to the power negative 1. There is no need to know how to calculate x prime x or x prime y or the inverse of x prime x, as any statistical package can be used in order to calculate these matrices. But now what we need to know is how to find the value of beta using x prime x to the power negative 1 and x prime y. So we have to multiply a matrix with a vector in order to get a vector. So we can write it as Beta equals x prime x power negative 1 multiplied by x prime y. So it will be calculated as multiplied by the vector, which is 55, 1, 3, 4, 8, 4, 7, 2. Okay. So multiplication of a matrix with the vector will be multiplied as a row multiplied by a column. And then we are going to get the second row multiplied by the column. So we can write it as 20.423 multiplied by 55 plus negative 0.608 multiplied by 1348 plus negative 0.63 multiplied by 472 and then we are going to move to the second one. So this is the multiplication of, or the result of this calculation will be the value of B1. And then with respect to B2, it will be negative 0.08 multiplied by 55 plus 0.019 multiplied by 1348 plus 0.018 multiplied by 472 and so on. So this can be written as 6.321, 0.129, negative 0.474. So we can write the equation after estimation as y hat equals 6.34, which is the value of the parameter B1, plus 0.129, which is the value of the parameter P2 multiplied by x2, minus 0.474, which is the value of the parameter x3 B3 multiplied by x3. So this is the value of the three parameters after estimation. So now we have to test the significance of the model. Test the significance of the parameters. As we said before, that the t ratio or the t-test can be used in order to estimate the significance of the model, of the parameters. T ratio used to test significance of parameters. So in this case, we have to do the test 3 times. The first one with respect to B1, the second one with respect to B2, and the third one with respect to B3. So we can write it as H node, which is the null hypothesis, B1 equals 0, which means that has no significant impact on Y. H1, or the alternative, B1 not equal 0, which means has a significant impact on Y. And we are going to do the same with respect to B2 and with respect to B3. And as we said, in case of simple regression, this t ratio is calculated as the value of the parameter divided by its standard error. So if you know that standard error of B1 hat equals 1.68, and for B2 hat equals 0.056, and finally with respect to B3 hat 0.059. So now we can calculate T ratio of B1 hat as the value of the parameter divided by its standard error. So it will be 6.34 divided by 1.86. So it will be 3.4. The same with respect to B2, it would be calculated as 0.129 divided by 0.056, it will be 2.3. And finally, with respect to the last one, it's negative 0.474 divided by 0.059, it will be negative 8. So now we have to take a decision that in the three cases we are going to reject each node and accept each one, which means that the variables has a significant impact on y. Of course, we are going to talk about each one of them separately, where as the value of T calculated for B1 is 3.4, this means that B1 has a significant impact on y. In case of B2, 2.3, this means that income has a significant impact on consumption. In case of number 3, negative 8, so this means that interest rate has a significant impact on consumption expenditure. So this is with respect to the significance of the parameters. Now we are going to move on to the significance of the model or reliability of the model. As we said in case of sample regression, that we can test the reliability of the model using R squared or F ratio. Let's start with R squared. R squared is calculated as ESS divided by TSS. Or in other words, ESS will be calculated using matrix notation as B prime X prime Y, while TSS is Y prime Y instead of Y squared. If you know that Y prime Y is 385, and now we would like to find the value of ESS, and actually we know that the value of B hat is 6.34, 0.129, and negative 0.474. And the value of X prime X is 55, 1348, and 472. Using the same method of multiplication. So we can find the value of ESS as 298.864. So this is the value of ESS and this is the value of TSS. So now we can calculate R squared as so it will be 0.776. So we can say that The explanatory variables explain 77.6% of the variation in y, or the model explains 77.6% of the variation in y. Now we can use the value of r squared in order to find the value of F ratio. So as we said before, that F ratio is calculated as r squared divided by k minus 1, which is the degree of freedom, divided by 1 minus r squared divided by n minus k, which is the degree of freedom. In this case, k will be equal 3, where we have to estimate 3 different parameters, and n will be 10, as we said at the beginning of our lecture. This is the end of our lecture today. Next time we are going to talk about OLS assumptions and what are the main problems associated with the violation of these assumptions. Thank you. See you next week.